Alright, today we look at asynchronously running Python blocks in org mode. If you've done this before, you know that when you run a Python block, it locks up Emacs until the Python code is done, and then it inserts the output below it for you to see. If that's going to take 10 or 15 minutes, it's pretty annoying, and you might like to do something else in Emacs while that happens. And you also might like to see some intermediate results from the code, which isn't currently possible. So I've been looking at a couple of ways to address this problem. The first way we'll look at is this async module. And this was written by John Weekly, and it allows you to launch an asynchronous process, and then when it's done, it runs another command that will do whatever you want. So one approach that we could take for this is to create a function. I call it org-babel async execute. I should probably put a Python in that name. And what we'll do is run this on a code block, and we will tangle that code block out to a file so that we can run the file through Python, capture the output, and then put it back in. So here's how we do it. We'll assume that our cursor is in a source block. Here we tangle it to a temp file. We remove the results from the source block and then insert at the end of it a new results with a name if we need to and a UUID. This will be a long random looking string that we will replace later. Now the start function that we want to do is just to run a shell command and capture the output as a string, and the shell command is just Python with the temp file that we made, and when it's done we delete the temp file. Now this function should return the output of this command, and the second function to async start is what we run afterwards, and we want to save all of these restrictions, excursions, window excursions, so that wherever we are, this function gets back to the original file we called it from, goes to the beginning, searches for our UUID, kills that line, and then we're going to insert the results. So the results down here, I split it by carriage returns, and then I add colon space to the beginning of each line, and I do that for every line but the last one, which is just an empty carriage return. So that's the idea. So let's execute this, and here is a little code block. If I run org-babel async execute, then what you see is we get the UUID, and a little bit later it is put in there. Let me run that again and show you that we can move around while it's happening. Right, so this is now moving, and in about a second or two that should get replaced, and there it is. Right, so I can run a Python code here asynchronously. Now I don't know how much I like the idea of tangling individual code blocks, and we still aren't able to get any kind of intermediate feedback on the code. So the next thing we're going to look at is how to implement that as an Emacs process. So Emacs allows you to start a process asynchronously and attach a Sentinel function to it, which is probably what that async module actually does. But this is the start to getting towards that interactive information. So here we take a slightly different approach. I'll redefine this function here, and we're still going to tangle the file, but we will use the Emacs process to get that. So basically the same layout as before. We define some temporary variables, we tangle our code block out, we remove the results, put this in, and here we start a process that has a name of our UUID. It'll put output into pbuffer, and our process is just going to be Python running on the temp file. And now we set a process Sentinel. This is going to be a function that runs at the end. And so when the event for that process Sentinel is finished, then we'll delete our file and we'll do the same excursion that we did before of making sure that we can do this. Alright, so let's try this one, and just for fun, let's split the window, and down here let's make this 5 again, and actually let's make it 10, and we'll run our work Babel. There's our thing. And now if I switch to, say, Scratch, and I come down here and I do some work, you can see that over here that got put in the right place even though I was working in this other buffer. Okay, so that got us a little bit closer to being able to see the output. We get the output from pbuffer now as this buffer string, which means we might be able to look at it if we wanted to. So the next iteration is to solve two problems that are left in here, and that is we still don't get the output, and it still does the tangling. And so now we're going to look at a very similar approach, but one that avoids the tangling. So the idea here is we still open a process, but we can send a string to it. So again, we're going to set up a process, remove the results. Here we create our process and tell it that it's going to get the code from standard in. We grab the code up here from the source block using org element, and then we send it to there and send an end of file to the process, and then stop the process so that it's finished. I think that's the right thing to do. And we again set a process sentinel for when it's finished, and the difference here is that the output will have a bunch of Python interactive characters like these three angle brackets and some blank lines, and so I like to clean all of that stuff up in this place here. But essentially I take the pbuffer and extract out the code or the results, strip out a bunch of stuff, add the colon spaces so it looks like it did before, and then when we're done we kill the buffer and delete the process. One big difference here is that we can actually switch to the to that buffer if we wanted to and watch it. So let's see, that's done right here. We will switch to that other window, to that output buffer in another window so that we can see it, and then when we're done we'll get rid of it. Alright, so let's check out that, and here let's also do for I in range of 5, print I, just so we have some things to see. And now if we run this, we see a little window here. It's going to pause for 10 seconds while it runs this line up here, and then when it's done it should print 5 things like so. We can see the output, and it's done, and it puts in the output down here. So I can see here this colon colon colon, that ought to get removed because I don't like to see those, but otherwise it's pretty good and gives me asynchronous work and allows me to capture the output and see what's happening all at the same time. So I find that pretty good. Obviously it works for this kind of simple example, and I don't know if it would work for other ones that have, say, variables in the source block up here, or other kinds of things like that org mode is good for. But for this limited kind of perspective, it seems to work pretty well. That's it for today.